All right, so 2.2, power functions with modeling. So basically, think back to, I want to say it was like 1.3 maybe. But we're going to be looking at power functions and variation. Okay, and within that, what I meant when I said refer back to 1.3 or 1.2, whatever it was, we talked about the basic functions, 12 basic functions. Okay, 5 of the 12 basic functions are power functions. Okay, so I would say make sure you know what those are. Go back and look through them, find out what they are, and write them down. Okay, that could potentially come up as a question at some point, maybe an extra credit question. I don't know. It just depends. Anyways. So we have a definition here. Any function that can be written in the form f of x is equal to kx to the a, where k and a are non-zero constants is a power function. The constant a is the power, k is the constant of variation, or constant of proportion as the case may be. We say f of x varies as the eighth power of x, or f of x is proportional to the eighth power of x. Okay, so this is a raised to the th. So basically whatever that power is, it could be 4th, 5th, 6th, 7th, okay, whatever it is, that particular power of x. Okay, so a couple things that you should be familiar with, some common ones that you should make a note of, are some common geometry and science functions. Okay, so we're going to have the name, and there's going to be 4 of them that we're going to talk about. So name, formula, power, constant of variation. Okay, so COV is constant of variation. I'll write that up there so you can see. All right, so we have this table to fill out. As I launch a marker. So we're going to start out with circumference. Hopefully these are readable. So the formula for circumference, hopefully you remember, is C is equal to 2 pi r. R is just raised to the 1, so it's got a power of 1. Constant of variation is the number in front of the variable, so it's going to be 2 pi. Keep in mind, pi is a number, not a variable. The area of a circle is A is equal to pi r squared. R is being raised to the 2, so it's a power of 2. Constant of variation is the number in front, so that's just going to be pi. I feel like this is getting out of focus, so let me get it focused back in real quick. Alright, so then we have the force of gravity. And that's going to be F is equal to K over D squared. K, and that's the D being squared, not the K. Hold on, let me make sure. Yeah. So our power is going to be negative 2, because this is going to go up to the top. To move it up, it's going to be negative 2. Constant of variation is going to be K. Okay, so K is just a number here. So basically, I could rewrite this as K d to the negative 2. Okay, if I wanted to rewrite that. And Boyle's law, V is equal to K over P. Okay, where P is our variable. So this is going to be P raised to the negative 1, so I could write this as K P to the negative 1. So my power is negative 1, constant variation is K. Alright, so maybe you remember back in Algebra 2, we talked about direct variation, and we might have done a little bit with inverse variation. I can't remember if we touched on that, but if we didn't, I'm getting ready to give you the definition of those now. So first of all, direct variation this is a power function formula with positive powers. Okay, and then the other one, inverse variation is a power function formula with negative powers. Okay, and then make sure you remember back to like the definitions of a monomial, a binomial, trinomial. I don't remember if that was this class that we did that in the other day. We were doing something similar to this in Algebra 2 also, so I can't remember what we touched on. I think we did the definitions of those things in here, though I'm not 100% positive if we did. Anyways, but remember, a monomial is something where you have a number and a variable, just a number, just a variable, etc. A binomial would be two pieces, so like 3x plus 1. A trinomial would be like 2x squared plus 3x minus 2. Okay, something like that. So just keep those in mind, and we'll do some examples here in just a minute. Because honestly, this is really all of the notes for this section. So, yeah, that's literally the notes. So we're going to go through some examples, and then tomorrow in class, you guys will have the time to work on the problems and stuff like that that I give you here shortly. So, problems 1 through 10. say to determine whether the function is a power function, given that c, g, k, and pi represent constants. For those that are power functions, state the power and the constant of variation. So I'm going to try to give you guys as many examples here as I can to run through it and just make sure you guys are set and good to go with that since I am not here. Anyways, so starting with number 2, we have f of x is equal to 9x to the 5/3. So I want to know what my power and constant of variation are. Okay, if it's a power function, okay, I want to know that. So my power is the number that x is being raised to, so it's going to be 5/3. And my constant, okay, constant of variation, you can just write COV, is the number that's in front, and it is 9. Okay? I need to check this next one and make sure it's not trying to be tricky. Okay, yeah, we're good. We are good. It is not trying to trick us or anything. So number 4, f of x is equal to 13. Okay, well, do I have a power? Is there a variable that's being raised to something? The answer to that would be no. So I have a power of 0. Okay, x to the 0 would be 1. So we would say there's a power of 0. So if there is no variable listed, okay, so there's no x here, that means that the power is going to be 0. Okay, so it's a 0th power constant function, basically. Constant of variation, or you can just say constant, whatever, is going to be 13, so it's just the number. Number 6, okay, E of V is equal to 1/2 kV to the 5th. Okay, so what power is this one? Hopefully you recognize this is the 5th power. Okay, V is being raised to the 5th. Okay, and then the constant of variation is going to be 1/2 times k, because we said at the beginning that k is a constant. So 1/2 k is going to be that particular one there. Okay, now this next one is a little tricky. Okay, not really, but in a sense it is. Okay, f of a is equal to m times a. Okay, now this is force is equal to mass times acceleration. You should recognize that as Newton's law, or one of his laws of motion. Physics people at least should. So here, we don't know which, if I just were to look at this side, I have no idea which thing is my variable, what it's being raised to, what my constant is. Okay? We weren't told that m or a represents a constant. But what I do know is this says f of a. Okay? Normally, that says f of x. X is our variable, and so we are replacing it there with that particular, with whatever goes here. Sorry. This is our variable, thus that would be our variable. This is going to be our constant. So what power is it being raised to? Well, a is clearly just being raised to the 1, so it's going to be a power of 1. And our constant of variation is going to be whatever's in front, which in this case is just going to be m. All right, so then we've got 11 through 16. So it's to determine whether the function is a monomial function, given that L and pi represent constants. For those that are monomial functions, state the degree and leading coefficient, and if they are not, explain why. Okay? So, some things we have to know about a monomial. It has to have a positive exponent. Okay? You can't have a variable in the exponent. And you can't be like adding stuff together, things like that. Okay? So, work our way through these. So 12, we have f of x is equal to 3x to the negative 5. So based on the things I just said, is this monomial? Okay? No, it's not. Hopefully you recognize we have a negative exponent, so we need to say not monomial, and then just say negative exponent. Okay, so that's what I would expect to see if I were to ask you that question on a quiz or a test. Okay? 14. Y is equal to negative 2 times 5 to the x. So here, is this one monomial? And don't be confused by the fact that this is a negative 2 times a 5, okay? Just because that's two pieces there, they are technically being multiplied, so that doesn't discount the fact that it could be monomial. But what does is the fact that I have a variable in the exponent. So it is not monomial. Variable in the exponent. Okay? 16. A is equal to L times W. So this is the formula for area. So, do we know for sure what the variable is here? Not entirely. Is this monomial? Well, I have two things being multiplied, so that would tell me yes, it is. So, when I look at this, I will be looking at the fact that it is L times W. You can really pick either variable, technically speaking, to claim as your variable and the other thing to be your leading coefficient. I would say always pick whatever's in front to be your leading coefficient and whatever's behind to be your degree. So yes, it's monomial. Degree, W is just being raised to the 1. So it's a degree of 1, and a leading coefficient, it's whatever's out front. In this case, it's going to be an L. Okay, if you want to list this as LC for a leading coefficient, that's fine as well, just to shorten it up a little bit. All right. So now, getting into stuff like 17 through 22, okay, some of these I'm going to go ahead and tell you, you kind of just have to know, which is really annoying in a sense because they're pretty effective, but basically, if we do it in the examples here, or you do it as a homework problem, it is fair game for a quiz or a test. Okay, I'm not going to pull some of these other ones out unless we have specifically done them. So, number 18. Okay, and I also expect you guys might have more questions about these ones, so just if you are doing the homework and you don't understand, just put a little star by it, put a question mark by it, and remember to ask me when I return on Wednesday. Okay. So the volume V of a cylinder, or let me rephrase, of a circular cylinder with fixed height is proportional to the square of its radius. Okay, and it tells us to use K for the constant of variation if one is not given. Okay, so it tells us that it's got a fixed height, okay, meaning that's not changing. Okay, we're looking at our volume. Its height is proportional to, or with a fixed height, is proportional to the square of its radius. So, basically, any numbers that would be out front, we are going to call K in this sense. Okay? So, our normal equation for a cylinder for volume is V is equal to pi r squared h. But h is constant, okay? It is fixed, okay? And we know that we're using K as the constant, okay, per the instructions. So V is equal to pi and h I'm going to relabel as K r squared. So K r squared is what I'm looking for in this particular one. Okay? Some of them I won't expect you to know, like 19. I don't expect you to know that formula. But a hint is that V is equal to IR. So when you go to do that problem, see if that helps you there. And see if you can, you'll also see if you can figure out 21. I don't really have a hint, but any of these ones you will try on your own, okay? We're not done, but just 17, 19, and 21 are ones that you should try. The answers are in the back, but please try them by yourself before you just do them. Try to understand where they're coming from. And if you don't, when I get back, we can go over it and make sure you understand everything. All right, so 23 through 26 say to write a sentence that expresses the relationship in the formula using the language of variation or proportion. So let's do a couple of those. We'll do 2 of those, and then basically whatever time is left, you guys are welcome to work on, like I know you might have some stuff to study for or something, so you can do that, and then you'll do your problems tomorrow in class. Or if you know you have something you need to study for tomorrow, you can work on the problems at the end of class. But I am leaving you plenty to do to make sure that you stay busy, and these problems should go pretty fast, so just be aware of that. Okay? All right, so number 24. And I'm not going to copy down the whole problem, so I would just say grab your book and look at it. It's on page 182. So basically we have C is equal to pi d, so I'm going to go ahead and write that. C is equal to pi d. C and d are circumference and diameter of the circle, and pi is its usual mathematical constant. Okay, so we want to write a sentence that expresses the relationship in the formula using the language of variation or proportion. So basically we know that circumference is 2 pi r. We know that it's pi times its diameter. So we want to think about what wording we need to use. So if we're multiplying, okay, we are going to say that it is proportional. So basically we're going to say the circumference C of a circle is proportional to its diameter, d, with the constant of variation, pi. Okay, and I'm just going to write COV to shorten that. Yes, I know it is a little bit out of focus, so I'm going to try to get it back in focus here. We just have one more example, and then we will be done. All right, so then let's look at 26. Okay, like I said, this will be the last one. And this will be all we're doing with this section. So we have d is equal to p squared over 2g. And immediately, I don't know what that formula is, so let's find out. Where d is the distance traveled by a free-falling object dropped from rest, p is the speed of the object, and g is the constant acceleration due to gravity. Physics people, hopefully you know what that is. Okay, if you're not, just so you guys are aware, g is a constant 9.81 meters per second squared. That's the acceleration due to gravity. Fun fact for you, if you haven't taken physics, there you go. Anyways, so I want to basically rewrite this in a manner in which it makes sense to make a sentence using the words basically proportion or variation as the case may be. So the distance d traveled by a free falling object dropped from rest varies directly. Okay, so that's what I was looking for there. Varies directly, and the other one I was looking at proportion. So varies directly with the square of its speed p with the constant of variation 1 over 2g. Okay, so there is a lot more we could do with this section. There's a lot of problems, like 27 through 30 is pretty much the same thing we've already done. It just wants us to look at it in a little bit of a different manner. But as far as I'm concerned, that is sufficient. We could possibly look at a word problem when I get back to actually look at one of those. But honestly, I think this stuff is pretty sufficient for what we need. So let me go ahead and assign you your homework problems. And like I said, I am going to give you a lot because I really don't think it's going to take you that long, and I do want you to stay busy. You can complete it today if you would like and post it, or you can wait and do it tomorrow if you have something you need to study for today. But I also probably will leave some extra problems, and so if you guys are goofing off, talking, whatever, not doing your work today or tomorrow, or not studying for something else, I will leave some extra problems that you guys will be responsible for as well that I might grade on if they are right or wrong, not just if you complete them. So, please, please, please use your time wisely so you don't end up getting stuck with extra problems. Okay? So your homework for this section, and I'll try to remember to post it on Google Classroom prior to me leaving as well, is going to be 1 through 25 odd. Okay, I know that sounds like a lot, but they're really not that hard. Okay, and if you have questions, just again, you have to do the problem, you have to attempt it, but just if you really don't understand, put I don't understand, or I'm not entirely sure what's going on here, and I will work with you when I get back.